Excuse me. We've talked about how to solve triangles when we have right triangles, but oftentimes, we don't have right triangles, and we need to figure out how to solve triangles when we don't have these right triangles. We're going to have to remember a little bit of geometry for this. And if we have a triangle, you recall that the angles are labeled in capital letters and the sides in lowercase, with the side going across from the angle that opens up to it, matching the letters. Now, in geometry, we had some congruency terms that we used. And these are all the different congruency terms that we have. We said that this was going to give us one triangle. If we knew that the three sides were congruent, and then we would have one triangle that was congruent. And the side with the angle between the sides, so if we had B and then angle A and then side B, side C, the ones between it, then we would have a matching triangle. And if we had a side and the angle next to it and then the angle across from it, then we could have one triangle. Or if we had the angle and then the side between these two angles, we would have one triangle. And we could get these congruent to each other. We did congruency proofs in geometry. We also recognized that if we had angle, 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 then that gave us an infinite number of triangles. It only proved similarity. Remember, because all the angles could be the same and then the sides be different lengths. So that would just prove similarity. Now, we also had side, side, angle, and if this is true, we have a side and then a side and then the angle. Remember, these are in order. This gives us multiple possibilities. And so we'll address that as well. So that's a little geometry review about triangle congruency. Hopefully you remember at least what it means to have these little triples here. Remember, it's in order, all the sides. This is the angle between the two sides. This is a side with an angle next to it and then an angle going around the triangle. This is the side between these two angles. This is two sides next to each other with the angle next to it. So this is, as you go around the triangle, what you hit. Now, in order for us to deal with triangles that are not right triangles, we have a couple of different laws that we use. The first one we're going to talk about is called the law of sines. Now, the law of sines is for when we have angle, side, angle, or side, angle, angle, or side, side, angle. So these two choices here will have one triangle solution, and this one will have multiple possibilities. So we'll figure this out and be able to show what those multiple possibilities are. So the law of sines looks like this. If you set up a ratio between the side length and the side and the sine of the angle opposite it, it's equal all the way around the triangle. Now you, of course, can also write this with the sines on top, as long as you're consistent all the way across. So this is the law of sines. You need to know the law of sines and when to use it. So here's the law of sines. We use it when we have a situation where we're given a side length and two angles and we want to find the rest of the things in the triangle. Or we're given an angle and a side length and another angle and we want to find the rest of the things. Or side, side, angle. Those are our three times when we're going to use the law of sines. So let's look at an example. Let's say that we're given that C is equal to 8, angle B is 35 degrees, and angle C is 70 degrees. You will save yourself a lot of headaches if every single time you do one of these problems, you first draw out a triangle, label the sides with their letters, and then start putting in numbers. So we label our triangle with our letters, and then look, C is equal to 8, angle B is 35 degrees, and angle C is 70 degrees. So what is this? We have the side as we go around the triangle, and then we have an angle, and then we have an angle. So side angle, angle, that's a time when we'll use law of sines. So what we can do is we see that we have both the C components there. So since we're looking for side length, so I'm going to put the side length on the top. So we have 8 over the sine of 70 degrees equals, now we already have B angle, so let's find B side first. So we have B over the sine of 35 degrees. Now of course this is just algebra, so we need to solve, we can solve that. And we can also know that, what's this angle here? That's right, 75 degrees, because how do we know that? 180 minus 70 minus 35, 75 degrees. So we can also set up our ratio for A. Now, of course, you don't want to solve it with multiple equals, so we'll solve one at a time. So if we solve this one, we have B equals the sine of 35 degrees times 8 all over the sine of 70 degrees. So you make sure your calculator is in degree mode, make sure you've got parentheses around this all nicely, and you get that B is 4.886, I believe. And then A, we can use these. It's best if you use the original one instead of using the B, because we rounded this. So we want to make sure we're using the one that's the most accurate. So we have A equals the sine of 75 degrees times 8 all over the sine of 70 degrees. So A equals 8.223. So we have this side length, and this angle measure that we needed to know because there's 6 parts in a triangle. We were given these 3, and we found out the other 3 using the law of sines. So that's what happens when you have side angle, angle. When you have angle, side angle, it's a similar thing. It's just instead of, you'll find your other angle using the 180 minus thing to find your other angle, and then be able to set up your ratios there as well. So what happens when you have side angle? That's a little bit different. When you have side angle, so we've got 2 sides that are next to each other. So for example, we could have C and A angle, or sides, and then angle C. Or we could have BC and angle A, or AB and angle A, or sorry, BC and angle B, AB and angle A. So as we go around the triangle, we've got 2 sides and an angle. There's 3 possibilities. You could have no solution, which means that the information that they've given you doesn't actually create a triangle. You could have 2 solutions, which means that the information they've given you will work for 2 different triangles, one of which is acute and one of which is obtuse usually. Or you could have 1 solution. So let's see if we can work on this. So if we have, for example, A is 9, B is 12, and angle A is 55 degrees. Well, let's look at this. If we have angle A is 55 degrees, and let's call this C, and then we'll go ahead and draw it as a triangle, hoping that it'll work out, but it may not. So if this length is 9 and this length is 12, the way you test this is you have to use some geometry that hopefully you remember, and you have to drop a perpendicular here. This is the height of the triangle, right? What we need to know is what this height is so we can tell if this actually makes a triangle. So the height of the triangle is, remember, opposite over hypotenuse is your sine. So the height divided by 12 is going to give us the sine of 55 degrees. So the height would be the sine of 55 degrees times 12. So in this case, the height is 9.8298. Well, look at this here. If we have this height is this, and we have this here, what do you notice about this triangle? What always has to be true about a hypotenuse? The hypotenuse of the triangle always has to be longer than its legs. If the height is 9.8298, we cannot have a hypotenuse of 9. So this is not going to make a triangle. So this has no solution. Now the way we test this, no solution happens when we have our side length is less than the other one times the sine of the angle that we're given. Okay, so you need to make sure that you write this out, but you can just look at it and think it through with your geometry and realize. But this is kind of the formula. If our side length is less than the other side times the sine of the angle that goes with this one, then we won't have a triangle because the hypotenuse has to be longer than the height. Now, the other thing that if you set it up, if you were to set this one up, just assuming it was going to work, you would set up this 9 over the sine of 55 equals 12 over the sine of b, and you would get the sine of b equals 12 times the sine of 55 degrees all over 9, and that means the sine of b is 1.0922. What do we know about sine? It has to be between -1 and 1, so this doesn't work. So that's another way to tell you that you have no solution. All right, so what about our other situation? What about two solutions? How do we know that happens? Well, once again, we're going to be looking at the height of the triangle that we're trying to make and see if that works. So when we are given given information on a triangle, for example, if we're given that b equals 13 and c equals 14 and angle b equals 64, then we have a triangle we can draw in and look at the height again. So we've got, remember, draw your triangle, label them all with the letters first so that you can make sure you're getting them right. So then we have b is 13 and c is 14 and angle b here is 64 degrees. All right, so we need to see about the height and what happens with it. So if we drop a height from A, you don't want to drop it from the angle that you know. So if we drop a height from A, this is our H, write it sideways there. It's probably confusing. There, is that better? All right, so H is, remember, H over 14 is going to give us the sine of 64. So 14 times the sine of 64 degrees. So H equals 12.5831. So we look at this and we say, okay, that's smaller than our hypotenuse here, 13, so that could work. And so we know we have at least one solution. So now we've got to figure out if we have what solutions we have. So the first thing we want to do is find our angle C, because it's across from the side. So we're going to look at that and we're going to say the number we know, 13b, which is b, over the sine of 64 degrees, equals 14 over the sine of C. So we do our cross multiplying to get this all figured out, and we have the sine of C is 14 times the sine of 64 degrees over 13. So we calculate this all out and then take the inverse sine so that we get C is equal to 75.4507 degrees. Now, that gives us what C has to be. In one case. But we could have another case. It could be that this is just our reference angle. Because remember, when we take the sine, if we have an angle over here, we're using this reference angle to get the sine, even though we're talking about this angle here. We could have a second scenario where we have something more like this, where this one's the 14 and this one's the 13 and this is 64 degrees, and we could have this angle instead. So what is that? Well, 180 minus 75. So our other possibility is we could have that this is 104.55 degrees. Now what does that make our third angle? Well, in this case, it makes angle A to be, write this out here, angle A to be 40.55 degrees, because remember, a whole triangle is 180. And in this case, it makes it out to be 11.45 degrees. So that'll work there. Now, we use both of these. So we're going to have two different things that we're going to calculate to find side A. We're going to have, for this triangle, we'll call this triangle 1. We'll set up 13 over the sine of 64 degrees equals, remember, we're using that original one that we know everything on for our ratio so that we can solve here. And we use this angle, and we get A is 9.403. And then for this triangle here, our second possibility, then we get 13 over the sine of 64 degrees equals A over the sine of 11.45, use that other angle this time, and we get A is 2.871, so A is much shorter this time, obviously, since the angle across from it's smaller. So these are our two possible solutions. Okay, this happens when our height, which is B sine of A, is less than both given sides. Okay, so that's what happens when we have two solutions. Now, I'm just going to go ahead and erase this, so hopefully you've got all of this part in your notes so you can go back and look at that. Now, what happens, we've seen what happens when the side lengths are smaller than h and when h is smaller than both the side lengths. What happens when the side length is equal to h? Or, this one's going to be a little tricky sounding. The side whose angle you know is greater than or equal to the side whose angle you don't know. Let's put this over here. This is when we have one solution. So what does that mean? Well, let's say we've got B is 18, C equals 9, and angle B equals 82 degrees. So we draw our triangle, Remember, when you're sketching your triangle, it doesn't necessarily have to be to scale and accurate. Mostly you're just trying to place your sides and your angles across from each other properly. So B is 18, C is 9, and angle B is 82 degrees. So the side whose angle we know is this one. We know the angle across from it. If that is bigger than the side whose angle we don't know, then we have one solution. Or when the side equals the height. Remember, the height we found, if we dropped across from the angle we want, not one of the angles we know, then for this one we would have the height equals, well, the sine of 82 degrees is h over 9, so 9 times the sine of 82 degrees, and we have h is 8.912. Okay, so this is less than that, so it's not equal to. So this is when we would look at it and say, okay, does it have two solutions? Possibly. So then we look at this, so we know if we have to narrow it down. Remember, on our last example, the side whose angle we knew was 13, and the side whose angle we didn't know was 14. So this didn't work. So that's how we ended up with two solutions. But this one, it does work, so we're going to only have one solution. Basically what that tells you is that obtuse option isn't possible. So how do we solve this one then? Well, we are looking for some angles. So we've got the sine of 82 degrees over 18. Remember, always set up with the one that you know both parts of first, equals, let's just find C first because that's the one where we know the side on. So the sine of C equals 9 times the sine of 82 degrees over 18. Plug this all in your calculator, make sure you're in degree mode, then take the inverse sine, and you get that C has to be 29.68 degrees. So now, how do we find angle A? Right, a triangle is 180 degrees, so we say 180 minus 82 degrees minus 29.68. So then we've got angle A has to be 68.32 degrees. And we can use that, remember, set up with the one that you know everything of from the beginning. And, oh, whoops, we're looking for a side length. When you're looking for a side length, you want to put that on the top. You don't have to, it just makes it easier. So we're looking for side A. And we set that all up and multiply this up here, do our cross multiplying. If you're having trouble actually solving these, come see me, because I'm expecting that you know how to cross multiply and solve rational equations at this point. All right, so then we've got all our three parts that we're missing. So the first thing you need to do is decide how many triangles you have and then solve it. So if we have side, 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 angle, side angle, or angle, side, angle, then we're going to have one triangle. Remember, only angle, side, angle, and side, angle did we use the law of sines for. The others I'll show you a different law in the next video. Remember, side, side, angle, you can have no solution if that height is bigger than the side that you don't know the angle on. Or you could have two solutions if the height works out, but your side whose angle you know is smaller than the side whose angle you don't know. Or you could have one solution if the height works out, but your side whose angle you know is greater than or equal to the side whose angle you don't know. So make sure you know which case you're dealing with first before you start trying to solve it, and then find those three pieces. This is a little bit complicated. It takes a lot of stuff to remember. If I were you, I would take the time right now to write yourself a little summary, maybe an index card or something, of a little formula where you write down the law of sines, which cases you use it, and how you know how many triangles are part of your solution. If you don't compress it into that for yourself right now, you're going to have trouble with this. You need to do that, and you cannot expect me to spoon feed you which case you got every single time. That is something you will have to figure out. So make sure you understand this. Write down any questions you have so that we can answer them in class.